Let's take this problem of, actually it's problem number 34 of your textbook. This problem says a string is wrapped on a wheel of moment of inertia 0.2 kg. This is the wheel actually of radius 10 centimeter. So radius of this wheel is 10 centimeter. Let's write down 10 centimeter. This is equal to 0.1 meter. And moment of inertia, is given as 0.2 kg meter square. 10 centimeter goes through a light pulley to support a block of mass 2 kg. So this mass is 2 kg. As shown in the figure. Find the acceleration of the block. Now, of course, this block will drop down. They want us to find out the acceleration of it. Now, in this problem, I want to point out one thing to you, which is very useful, that these two pulleys, there is a difference of these two pulleys. Look at the question. Goes through a light pulley. That means this pulley is a very light pulley. Whereas this pulley has a moment of inertia. The number 2 pulley, or the pulley with the thick line, has a moment of inertia. Now, so far, earlier in various kinematics chapter, you have always seen it's a light pulley. It means the pulley is so light that the system does not waste any extra energy or force or tension in rotating that pulley. So, the physical characteristics of that light pulley was always ignored. But coming to this chapter, you will find sometimes it is mentioned such and such pulley, its moment of inertia is such and such. That means that pulley is a heavier pulley. And when you solve the system kinematics, we have to consider the pulley, the torque, moment of inertia, etc. of that pulley. This the student should be very careful of. There are two different pulleys, different types of pulleys. Anyway, here, this thick pulley is the heavier pulley, which has got a moment of inertia of 0.2 kg square. And the other pulley, thin pulley, is a light pulley, and there is a mass of 2 kg, which is dropping down with an acceleration A. We have to find out this acceleration. Now, as I said, this light pulley, this pulley is a thin pulley, so tension of the string on either side of the pulley will be same. This is very important. But if the pulley itself is a part of a kinematic system, then the tension on the two sides may not be set. This you have to be very careful of. Understanding this, solving this problem is not very difficult. Considering the mass 2 kg, so we write considering the 2 kg mass, we can very easily write the downward force 2g minus tension T is equal to downward acceleration m into downward acceleration A. There is no doubt in this. This is equation 1. This we have done right from the beginning of the physics lesson. And for considering the larger pulley, now considering the larger pulley, what is our observation? There is a tension in the left side direction, though, so there will be angular motion in this direction, and there will be an angular acceleration. There will be angular acceleration alpha. Now, what is the torque applied by the tension T? Torque is the tension multiplied by radius of this pulley. So we write For this question, we write everything. For the questions later on, we will not write so much. Torque applied by the tension T is equal to T multiplied by radius R, which is equal to, which is R is given. We will not put the values right now. We'll put the values later on. And this torque is equal to this torque is equal to, I alpha. I alpha. This torque is equal to I alpha. So this torque is equal to I alpha, moment of inertia into angular acceleration. So what we get? TR is equal to I alpha. So TR is equal to I alpha. From here, what we get? The tension T is equal to I alpha by R. I alpha by R. From here, what we get? Tension T is equal to I, moment of inertia I, by R, and alpha is itself the acceleration A by R. So there are two R's. So this is equal to IA by R square. So this is, if the first one was equation 1, let's say this is the equation 2. Now, one more thing I want to make you cautious about, that in such problem, the linear speed or the linear acceleration of the rope remains same all over the rope, right? Otherwise, the rope itself will get elongated or get compressed, whatever, unless it's an elastic rope. But the angular velocity of the pulley depends upon the radius of the pulley. If this radius and this second radius are not same, then their angular acceleration and angular velocities will be different. Like you may have a small gear and a large gear. So if they are in contact with each other, the tangential velocity at the contact surface is same, right? But the rotational speed of the two gears will be different. So this also you have to always keep in mind. Now from equation 2, we write from here, from equation 1 and from equation 2, what do we get? Get 2g minus t. 2g minus this tension T is given IA by R square. So IA by R square is equal to M. M is once again, okay, let me write MA, that way there will be no problem, into 2A. So from here you get 2G is equal to A plus I by R square A equal to 2 plus I by R square 2 plus I by R square A. So from there we get A. Now we get A equal to 2G divided by plus I upon R square. All these values are given. 2 multiplied by G is 9.8. That divided by 2 plus I is given as, moment of inertia is given as 0.2 kg per meter square, 0.2 kg meter, sorry, not kg per meter square, kg meter square, and R radius of the uh, R square is 0.2, 0.2 whole square. So R square is 0. The radius of this, radius is 0.1. Radius is 0.1 whole square. If you calculate this, you will find the answer is 0.89 meter per second square. That means this mass of 2 kg is falling at an acceleration of 0.89 meter per second square. This was the question. Now there is a tail end of this question. That is why I have taken up this question. There is a tail end of this question which says that there is a tail end of this question says that suppose the smaller pulley of the problem 34 has a radius and a moment of inertia. You got the real kick of this. Now, the smaller pulley also has a moment of inertia. And what is the repercussion of smaller pulley also having a moment of inertia, and its radius is also given? This radius is now given as, let us say this is R1 is given as 5 centimeter. That means 0.05 meter. And its moment of inertia is also given is 0.1. The bigger pulley, its values were already given. Now let us write this is R2 and this is R1. R2 was already known as 0.1 meter. That means that means the bigger pulley is double, its radius is double that of the smaller pulley, and its moment of inertia is also larger, and its moment of inertia is 0.2. Moment of inertia is 0.2, whereas the moment of inertia of the smaller one is 0.1. Now, this motion body is still moving downward with an acceleration A. Here, the question is not the acceleration. Find the tension in the part of the string joining the two pulleys. What is the tension here? Now, since the smaller pulley is not a theoretical light pulley, so tension here will be one thing, say take T1. Tension here will be something different, say T2. Because the system needs some work to rotate the smaller pulley also. Its moment of inertia is also given 0.1 kg. The question is, find out the value of T2. What is T2? So, obviously, solution to the problem is same as the earlier problem, but you have to consider the smaller pulley into the system. Smaller pulley into the system. In the earlier problem, this equation, this 2g minus t1, this equation, that is 2g minus t is equal to ma. Now it will be 2G minus T1 equal to MA. But the equation remains same. Obviously, the equation remains same. So we proceed this way. Now equation remains same. Like earlier, I write like in earlier problem, G minus T1 is equal to MA is equal to 2A. From here we get T1 is equal to 2G minus 2A. 2G minus 2A. Let's say this is equation 1. Let's say this is equation 1. Now, considering the larger pulley, both pulley has to be considered separately. Considering the, so let me write pulley 2. This is pulley 2, this is pulley 1. Considering pulley 2, the torque applied by the tension T2 is T2 R2. This is equal to I2 alpha 2. Why I write alpha 2? I write alpha 2 here. I write alpha 1 here. Because as I said, now tension T1 and T2 will be different. Angular velocities and angular acceleration of both the pulleys will be different. But only thing what will remain same is the linear acceleration or speed of the string. Because since the string is non-elastic, the string velocity cannot change. That is the only thing which is fixed here. So from here we get T2R2 is equal to I2 alpha 2. Now T2R2 is given as 0.1. I2 is given as 0.2. Alpha 2 is A divided by R2. Mind it, A remains same all throughout. This is equal to 0.2 into A by R2 is 0.1. R2 is 0.1. Right here, since A is equal to R alpha, so that you don't forget it later. From here, what do we get? We get T2 is equal to 0.2A, 0.2A, 0.2A divided by 0.1 multiplied by 0.1 is equal to 20A. 0.1 and 0.1 multiplication is 0.01 and 0.2 divided multiplied by 0.01 is 20A. So this is the T2 value we get. So we got the value of, this is say equation 2. We got an expression of T1. We got an expression of T2 in terms of linear acceleration A. Here also in terms of linear acceleration A. Now, do we have a relation between T1 and T2? Then, of course, this problem can be solved. Yes, there is a relation between T1 and T2. If you look into this pulley 1, if you look into the pulley 1, then considering pulley 1, what do we get? This pulley is rotating in this direction. So T1 minus T2 is the net tension on the pulley. T1 minus T2 is the net tension on the pulley multiplied by its radius R1. This is the torque. This is the torque. Let me write down, this is the torque. This torque has to be equal to I1, moment of inertia of the first pulley, multiplied by angular acceleration of the first pulley. This is equal to I1 into A by R1. A by R1. Mind it, A, value of A or linear acceleration is same all throughout. A by R1, right? Now, A by R1 is given 0.05. We shall look into it later on. This is T1 minus T2 is I1 A by R1, R1 I1 into alpha 1 is A by R1. So from here we get T1 minus T2 is equal to I1 A that divided by this R1 goes down here, that divided by R1 square, I1 A by R1 square. This is equal to I1 is given is 0.1. A, we going to find out the value. Divided by R1 is 0.05 and whole square of this calculated comes 48. So this is equation number 3. Now, we have come to the conclusion. So from equation 3, okay, we rewrite equation 3. We rewrite equation 3, that will be very wise. T1 minus T2 is equal to 48. Then using equations 1 and equations 2. Equation 1, I had the value of T1. Equation 2, I had the value of T2. So by using these two values, we get T1 was 2G minus 2A, 2G minus 2A, minus T2 was 40A, minus, sorry, T2, T1 minus T2 is equal to 40A. So T2 we do not know here. Here I made a mistake here. This is not 4A, this is 40A. T1 minus T2 is 40A. 40A. And T1 is 2G minus 2A from this equation, minus T2 is equal to 40A. From here, what do you get? Get 2G minus 2A, and T2 was also given 20A. So 2G minus 2A minus T2 is 20A is equal to 40A. From there we get, if we take A in A at one side, so we have 40A plus 20A plus 2A, 62A. So we have 62A is equal to 2G. 62A equal to 2G, or 62A is equal to 2G. So what we have to find out the value of, or A is equal to, from here you can write, or A is equal to 2G by 62. A equal to 2G by 62. Once the value of T2 was asked in the question, the T2 is 20A. And the value of A we have already found. So T2 is equal to 20A is equal to 20 multiplied by A is G by 62. So is equal to 40G by 62 is equal to 40 into 9.8 divided by 62. This you calculate, you will find a value of 6.32 Newton. So this is the tension T2 here, 6.32 Newton, and this is what they asked, right? So I think in this particular question, what we have learned, particularly, whenever you find it is mentioned that a particular wheel, a particular pulley has a moment of inertia, immediately your attention should go there that this pulley is a part of the system now. Secondly, remember, whenever there is a single string going over all the pulleys, the linear motion of the pulleys is, linear speed of the string is same all throughout. Unless the string itself is made of rubber and it expands. This is what you remember, that the linear speed or the linear acceleration A or the same thing is the surface velocity of the pulleys or the tangential velocities of the pulleys will remain same. But the angular velocity of the various pulleys will be various things. Number three thing what we have learned, that whenever there is a pulley which is not light theoretically, but the pulley has a mass and the pulley has a moment of inertia, then the tension on the two sides of the pulley is different because the pulley is a system. Obviously, tension in the pulling side will be more because the string will lose some energy in pulling the pulley itself, right? So this is it. Now we shall go to the next question for you. Just hold on.